Later materialists, those who are still interested in the basic question that Thales asked, what is everything in the physical universe made out of? Later materialists will come to the conclusion that everything is made of different things. What today we tend to call the four Greek elements. And this theory is a very useful theory. It explains all kinds of different things. And this will become the dominant theory, the dominant scientific theory in Western culture for almost 2,000 years. It's a very powerful theory because it explains an awful lot of things. I mean, that's what scientific theories are supposed to do. Explain the phenomena. Explain, how do I understand what it is that I'm seeing? How can I explain what I experience? The four Greek elements. Everything is made out of different things. In this case, four. The four Greek elements. Earth, water, air, and fire. Or to blow that up a little bit, earth, water, air, and fire. Earth, this theory holds that these elements exist in their pure form. Earth is, like dirt. That's a good starting point for thinking about Earth. Earth is hard stuff. Earth is earth. Water is water. Air is air. Fire is fire. That stuff's easy. This theory holds that these elements exist in their pure form. But they can also be broken down into little bitty pieces you can't even see. Can you imagine a little piece of water that you couldn't see or physically experience, but it would still be water? Or a little piece of earth, a little piece of dirt that would be so small you couldn't even see it, but it would still be there. Or a little piece of fire that would be so small that you couldn't see it. These elements can be broken down into little bitty pieces you can't even see. And these little bitty pieces you can't even see can be attached to each other in all kinds of configurations to make everything else in the physical universe that doesn't look like it's made out of earth, water, air, or fire. And this is a very useful theory. You can explain all kinds of things with it. I'd like you to follow just a few lines of thought with me, and to see how useful this theory very quickly can become. Imagine that you're out camping. You're camping next to a lake, and of course you've got a campfire, because you always have a campfire when you go camping. Well, now if you imagine this, you have all four elements in their pure form. You've got the earth, the stuff you're walking around on. You've got the water there in the lake. You've got the air that you're walking through, moving through, and you've got the fire there in the campfire. Now think of these four elements, earth, water, air, and fire. Now picture in your mind the scene here. Now forget about what the scientists tell you. Just use your common sense. Which of those four elements is the heaviest? Earth, water, air, or fire? Earth, right? Because earth is at the bottom of everything. Earth is at the bottom of the picture. It's at the bottom of the lake. Earth's at the bottom. What would be the next heaviest? Water. Because water sits on top of the earth, okay, there in the lake, but it also falls down through the air. What would be the next heaviest? Now, this one's tricky. Because probably about half of you want to say the fire, because the fire is down there sitting on the earth. But if you look carefully at the fire, or even at the picture of the fire you have on your screen, you see the flames jumping up into the air. So actually the fire is the lightest of all. Hey, it's fair if I ask you a tricky question, if I tell you in advance that it's tricky. You can't get too upset at me about that. The fire is the lightest of all. But maybe there's other stuff around that doesn't look like it's made out of earth, water, air, or fire. Like maybe the logs that you're throwing onto the campfire. Now, Thales had argued that the wood is made out of water, but he argued everything's made out of water. We've moved past Thales now, okay? The log doesn't look like it's made out of earth, water, air, or fire. Well, how would you tell what the log is made out of? How would you tell what wood is made out of? Well, you take it apart. To take something apart, you destroy it, okay? And so how would you destroy a piece of wood? Well, you'd set it on fire, of course. So you set the wood on fire. All day long it burns. At the end of the day, you've got a little bit of ash left where the log was. Now, what's the ash made out of? Earth, water, air, or fire? Earth, right? It's like fluffy, lightweight earth, okay? So you know that the wood had a little bit of earth in it. You see, what was happening as the log was being destroyed was those little pieces of earth were coming together, and when they got big enough, they were flaking out and falling down through the log into a pile on the ground. But now you started off with a log that weighed 20 pounds, and you ended up with, what, 4 ounces of ash? So you know there was a little bit of earth in the log, but you remember that while the log was burning, sap was dripping out of the end of the log. Now, what's the sap made out of? Earth, water, air, or fire? Water, right? With maybe a little bit of sticky kind of earth mixed into it, because when it dries, it leaves a little residue, but mostly water. You see what was happening as the log was burning were those little pieces of water that you can't see when you look at a piece of wood. I mean, if you look at, if I had a pencil or something made out of wood, I got nothing around me made out of wood, but if you look at something made out of wood, you don't see water. But sure enough, when you throw the log on the fire, then sap drips out the end of the log. So all those little pieces of water that you can't see were coming together, and when they got big enough, they were dropping out of the end of the log. You remember that while the log was burning, those little pieces of air were coming together, and when they got big enough, they would pop out of the log or hiss out of the log. So it had a little bit of air in there. But man, what's that log got a lot of? Fire. Once those little pieces of fire that you can't see when you look at a piece of wood, once they start coming together and they get big enough to start coming out of the log, those little pieces of fire you can't even see, and they come out of the log all day long. And now we can begin to put some things together and to see how useful this theory can be, okay? You might remember, although if you don't, it's no big deal, it was a throwaway line in a lecture that I gave to you, I forget how many sessions ago, but I mentioned the guy sitting next to his mountain stream. And he reaches over and he picks up a rock, and he throws the rock in his mountain stream, and it sinks down to the bottom. And then he reaches over and he picks up a stick, and he throws it in the water, and it floats downstream. And he thinks to himself, I wonder why. What would make a rock sink in water and wood float in water? Oh, rocks are heavier than wood. I guess I figured that one out. But that's really not true. Because I can take a little rock that weighs nothing. I can take a grain of sand that weighs nothing, and I put it in water, and it sinks right down to the bottom. But now I've been down to the docks, and I've seen ships that must weigh 20 or 30 tons, and they float across the water just fine. In fact, last time I was at the lake, I saw a great big log floating out in the water. It must have weighed 400 pounds, and it floats just fine. But if I reach down and pick up a rock that weighs nothing and throw it in the water, it sinks right down to the bottom. I wonder why rocks sink in water and wood floats in water. Well, now we know why. What are rocks made out of? Earth, water, air, or fire? Earth is like packed together earth, right? Well, earth is heavier than water. You put the rock in the water, it sinks down to the bottom. But what's the wood made out of? Well, the wood has a little bit of earth in it, holding it down, a little bit of water, balancing it out in the water, a little bit of air, pulling it up out of the water. But man, what's that wood got a lot of? Fire. All those little pieces of fire you can't see when you look at the log. They're so light, they lift the log right out of the water. You can make a ship out of wood and go sailing across the Mediterranean Sea just fine. All that lightweight fire trapped inside the wood lifts it right up out of the water. The theory works. It explains the phenomena. It explains what it is that we experience. That's what scientific theories do. They give us a way to explain our experiences, to be able to explain why something that I see or experience is happening the way that I appear to be experiencing it. We can explain all kinds of things with this theory. For example, here's a thought experiment. You've got two softball-sized ball bearings, I guess. One's made out of stainless steel. The other one is made out of wood. But they're the same size, about the size of a softball. Just imagine. You got one stainless steel softball-sized ball bearing and one wooden stainless steel softball-sized ball bearing. You're going to get them as cold as you can, within reason. And so you figure, I'm going to put them in my freezer at home, and I'll leave them in the freezer for a week. Surely after a week, they'll be as cold as they're going to get, within reason. And so you get a platter, and you put your stainless steel softball and your wooden softball on the platter, you stick it in your freezer. A week goes by. You figure after a week, they're going to be as cold as they're going to get. So you take the platter out and you put it on the table, and you touch the stainless steel ball and you touch the wooden ball. Now, which one? First of all, forget what the scientists tell you. Just use your common sense. Forget what the scientists tell you, use your common sense. Which of those balls is going to be colder? The stainless steel ball or the wooden ball? Of course you're right, the stainless steel ball is colder. You're right because I did what I asked you to. Forget what the scientist tells you, because sure enough, some scientist is going to stick his head around the corner with 2 thermometers and demonstrate that in fact they are the same temperature. They've been held under the same conditions for long enough that they've reached the same temperature. And in fact, when you apply the scientific instrument, the thermometer, then they don't use mercury anymore, do they? But the red liquid or whatever goes up to the same number on the scientific instrument. And by these 2 instruments showing the same number, then they demonstrate that they are the same temperature. That's what the scientists will say. But you did what I asked you to, which is ignore what the scientists will tell you, because everybody in their right mind knows the stainless steel ball is colder than the wooden ball. Who cares what the scientist says? Everybody knows the stainless steel ball is colder than the wooden ball. Which one are you going to touch to your tongue? The wooden ball or the stainless steel ball? The wooden ball. Because everybody knows the stainless steel ball is colder. Who cares what the thermometer says? Well, now we can explain why. What is stainless steel made out of? Earth, water, air, or fire? Earth is like cram-jammed earth, right? Why is the wooden ball warmer than the stainless steel ball? It's got all that fire trapped inside it. When you look at the wooden ball, you don't see fire, but that's why the wooden ball is warmer than the stainless steel ball. We can explain all kinds of things using this theory. That's why it will be the dominant scientific theory for almost 2,000 years. But it's a very useful theory. It does what scientific theories do. It explains our experiences. It explains the phenomenon that we appear to be experiencing. It's a very useful theory. And if it sounds strange to you to think about everything in the physical universe being made out of 4 things, that's not all that different from what they teach you over in chemistry class over in Building 2 here on the Ocala campus. You can walk in and they will find a chemistry teacher over there, and they'll tell you that everything in the physical universe is made of things called elements. Although there's more than 4 in the theory today. I don't know how many there are. The last time I checked, they said there were 112, I think, or maybe 108. I don't know. They keep changing their minds over there every semester as to how many of these elements there are. But however many they say there are, these elements exist in their pure form, but they can be broken down into little bitty pieces you can't even see. Guess what the Greeks called little pieces of earth, water, air, fire? Atoms. They call them atoms. Sound familiar? And that these atoms can be put together in all kinds of configurations to make, well, everything else that we experience in the physical universe. And that's a very useful theory. You can put these 107 or 109, however many elements there are this semester, you can put them onto a big periodic table of the elements and put it up on the wall. And if you have a good chemistry teacher, your chemistry teacher can explain to you how these elements relate to each other and how they all group together into different groups and classes and all this thing. And that's a very useful theory. You can explain a whole lot more with 104 elements, or however many there are this semester, than you can with only 4 elements. That's why they tell you there's 112. And you can mix the elements together and predict what will happen, and it's a very useful way of thinking about the physical universe. And really, when we think about what the materialists are doing, both Thales and the later materialists, but what are they doing? But wake up, computer. What are the materialists doing? There we go. But what, over in Building 2, what we call chemistry. If you take a chemistry class, what big question are you asking? What is stuff made out of? And you learn the dominant theory of the day and how you can mix things together and predict what will happen. You can explain what you see happening. It's a very useful theory. And really, what the materialists are really doing is what you and I would call chemistry.